So we're going to move right along into logarithm applications. And I have some examples over here on the left. So sound is a logarithm function, earthquakes, star brightness, and also pH, which we've all heard of at this point. It's just um, kind of the acidity of water, or any liquid for that matter. And so the equations for each of those are on the left. You can see that it doesn't really follow a particular pattern. Um, it was just kind of whatever exponential function, and then you take the inverse. So not really a form to follow for this one, but we can use the specific equations for their corresponding situations. So let's start with this example over here. Let me move my camera. Okay, so the intensity of an earthquake is measured between 2 and 10 on the Richter scale, and it can be modeled using the function r equals log of a over a sub 0. So this is the earthquake one, obviously, but what this function will give you is the r value between 2 and 10. So often on the news, you'll see like, oh, it was like a magnitude 3 earthquake or whatever. This is the function that they would use to get that number. And for the a's over here, I don't quite understand this because I'm not like a earthquake person, but basically the a on the top is like the overall amplitude of the earthquake, and then the a on the bottom is the smallest detectable wave. Again, I don't know the science behind that, but that is what the variables mean. So let's go ahead and answer this question. Do that in green. One earthquake is measured with a wave amplitude 392 times as great as its smallest detectable amplitude. What is the magnitude on the Richter scale to the nearest 10? And will it cause much damage? I guess we'll find out. So we're solving for r. We have the logarithm. And so it's saying that the wave amplitude, which is going to be a, is 392 times as great as the smallest detectable amplitude, which we said was a0. So we can substitute a for 392 times a0, because it's 392 times as great. And then that's going to be over our regular a0. So obviously, these are going to cancel. And so we're really just doing the log of 392, which ends up being approximately 2.6.